Today, we're going to compare the performance of our custom lighting models. Let's go! So we're in the middle of a series of videos on building custom lighting models. And by custom lighting models, I mean using the graph to alter the way that the lighting works. Typically, when you make a shader, you're just outputting the material properties like color, normal, smoothness, metallic, and ambient occlusion. But here, we're actually doing the math in the shader to control the behavior of the light. So we're controlling the diffuse, specular, and ambient light calculations. There are two main reasons for doing this. The first is because you want to give your game a unique look, to stylize it so it looks different from a standard, realistically rendered game. This is great for making your game's visuals stand out. Last week's video was a good example of this. We made a lighting model that's black and white, but it's colorized in places where there are point lights. The other reason to customize the lighting is because you need your game to run faster. You can remove some of the more expensive lighting calculations and go with simplified lighting to make the game run at a higher frame rate. This is especially helpful to do if you're running on a VR platform or a low-end mobile device. So we've covered all of these topics in the series, and I'll link the playlist for the series down below so you can watch the previous videos and see how to build these things. Since I've been talking about making the game run faster by simplifying the lighting, many of you have asked me to measure the performance so we can see exactly how much faster it is. So that's what we're going to do. That's what we're going to focus on in today's video. Before I show you the numbers, I want to show you the process that I've followed to measure the performance so that you can do something similar in your project. So as a control, what I've done here is I created a brand new project that has the URP garden scene in it in its original state before I started making any changes. So we can measure the performance score of this scene to get a baseline performance score, and then we can measure our custom lighting models to see if we've improved the performance of it at all. Okay, so let's kind of go through these steps. The first thing that I did is turn off the cameras that are associated with this project. The project has some fancy cameras that do kind of an automated fly-through and also allow you to kind of do a first-person walkthrough of the scene. And I turned off those cameras there, and then I added my own camera, and it's just a very simple fixed location camera. And this is very important because you want to always see your scene. When you're measuring performance, you want to always measure that performance from exactly the same place. So I placed this camera in my scene, and this is what the view looks like from my camera. And I set it up this way on purpose. It's kind of staring toward the ground. And the reason that I did that is because the sky back here is not using any of our custom shaders. Like, we're not customizing the sky at all. So the more sky that we show in our scene, the less we're actually measuring the changes that we're making with our shaders. So I set up my camera so that we're mostly just looking toward the ground, and everything in view is being affected by the custom shaders that we've created. Well, not in our control scene, actually. None of these are custom at all. This is just the vanilla garden scene exactly as it's available from Unity. But when we switch over to my project where I've been creating all of the custom lighting shaders, we'll use this same view. And what I wanted to do is fill the whole view with meshes that are rendered using the custom lighting that we've been working on. Okay, so we've set up our camera. The next thing that we needed to do is set up a way to measure the frame rate or the frame time. And so that's what I've done. I created a canvas element here, and you can do this just by right-clicking in the hierarchy panel, choosing UI, and then coming down here and adding a canvas element. Okay, so I added the canvas element, And then I set the UI scale mode to scale with screen size, and I set my reference resolution to 3840 by 2160 because we're actually going to be rendering our scene at 4K. Now, obviously, when you do this, you can set it to whatever resolution you want, but in my case, I have a very powerful graphics card, and so just to make sure that I can test it well, I'm going to be rendering it in 4K. All right, and then the next thing that I did is to my canvas, I added 2 Text Mesh Pro objects. So if I come down here and pick UI and then pick Text Mesh Pro, that's what I added right there. And if you haven't done anything with Text Mesh Pro in your project yet, the first time you do that, it'll pop up with a little box and ask you to download the basic set of Text Mesh Pro assets. So go ahead and do that. Okay, so the first asset I named FPS. Oh, and let me just, I'm going to hit F on my keyboard here so that we can take a look at our canvas item. And you can see that, let's see, you can see that our canvas item is quite large compared with the rest of the scene. And I'm not really sure why Unity does this, but basically the canvas is gigantic and our scene is this little green box down here in the corner. But that doesn't matter really because it's going to be applied to the screen once we're in rendering mode. Okay, so here is my FPS text object. We can kind of focus in on this. And you can see the positions that I've placed it in, -1094 and 677.4. And then I also came down here to the text input and I put -- space FBS. So this is the default text that we're going to display until it gets replaced. And I'll show you how to replace it in just a minute. All right, then I made a duplicate of that one and called it MS. And I put that at 1094 and 615. So it's just slightly lower on the vertical axis. And then I named it -- space MS. Okay, so I've got these 2 Text Mesh Pro elements. And then on my canvas, I came down here to the bottom and I hit Add Component. And I added this component called FPS Display, and it's a script. Now this is a script that I wrote that allows you to calculate the frames per second and the number of milliseconds that it takes to render the frame. So I hit Add Component, and then I hit this FPS Display. And that FPS Display script lives right here in my scripts folder in my project. And this is a script that I wrote, like I said, here it is. And I'm gonna link this script in the description for the video so that you can grab this and add an FPS counter to your project. It's really simple, pretty straightforward code, but so that you don't have to reinvent the wheel, I'm gonna link this in the description so you can just grab mine and use it. So I've added that FPS display script to my canvas, and then it added these 2 empty boxes. And what I did, this is the FPS text, and this is the frame time text. And so what I did is I grabbed my Text Mesh Pro elements, and I dragged those in to these 2 slots, just like that. And so when the game is running, what this script does is it calculates the frames per second, and then it adds those to these 2 text boxes that I've shown that are on the screen so that you can see what the frame rate is. All right, so that's my setup. Let's jump back into our scene here, and we'll just turn off all of the crazy looking UI elements there. So that's how I set up the scene. Now the next thing that I need to do is build this scene and run it with the editor closed. And the reason that I'm doing that is because if you try to measure the frames per second of your scene in the editor itself, the editor has a whole bunch of overhead. It's doing its own calculations on the CPU. It's using its own texture memory on the GPU. So there's a lot of things that the editor is doing in addition to what your game project is already doing. So if you're measuring performance inside the editor, you're actually getting inaccurate results. So you need to build your game and then run it outside the editor to actually measure the frames per second. And so in order to build, I'm going to come up here under File, and I'm going to pick Build Profiles. And it brings up our Build Profiles window. And I'm going to uncheck all of the boxes for all of the other scenes in my project, and I only want to build the garden scene. So I've turned off the terminal, the oasis, the cockpit. These are all other scenes that come with this URP sample. And we're only building the garden scene. Okay, and then I'll come down here and I want to make sure that development build is off because that's a debug build and it's going to slow things down a lot. I want to try to run the game at maximum performance. Oh, and there is one other thing that I want to check. So I'm going to come up here under Edit and pick Project Settings. And under Quality, I'm going to make sure that this VSync count is set to Don't Sync. And the reason that I want VSync count set to Don't Sync is because this will limit my frame rate if I've got it set to every V blank or every second V blank. This is going to put a cap on my frame rate based on the refresh rate of my screen. I don't, in order to measure performance, like normally if I'm running a game, it's good to have, you know, the performance sync to your refresh rate so you get nice smooth performance. But in this case, I just want it to show me the maximum possible frame rate. And so I'm going to turn off VSync there so that it will show me the frame rate as fast as it can possibly go. And then once all of those things are done, I'm going to come up under Build Profiles, and I'm just going to hit the Build button, and then I'm going to tell it where I want that build to go. And I've already done this offline, so what I'm going to do now is I'm going to run the project, and then we'll jump into the project when it's running, and we can take a look at it together to measure the frame rate. All right, so here we are in the project, and you can see I'm running at full screen at 4K, and if you look in the upper left corner there, you'll see it's running at 340 FPS. It's varying just a little bit, but it's hovering right around 340 FPS. And it's taking about 2.9 milliseconds to render this frame. 2.94. It might go up a little bit as my video card gets a little bit hotter, you know, 2.95. Let's just call it 2.95. So now I'm going to jump out of the game, and we'll open up the project that has our custom lighting in it. Now that we've measured this as our control, this is just the default scene without any changes to it. And then I'll show you the scene where I've changed the lighting, and we can measure the performance there as well. Okay, so I've opened my project where I've been creating all of our custom lighting. And what I did in this project, again, I turned off the cameras. I created a camera and I put it in the exact same location as it was in the other project. And I also set up the same UGUI canvas element that I did in that project with the same FPS and MS Text Mesh Pro elements. So the two projects are basically synchronized in the fact that they're rendering in the exact same location and they have the exact same canvas, FPS, and MS elements in them. So we're measuring the same performance. And now what I want to do is we're going to jump into our lit subgraph. And this is a subgraph that we've been building over the last couple of weeks as I've created all of the videos in this previous videos in the series. We've created all of these different lighting models. Here's the one that we created last week where everything's black and white except where the point lights are in the scene. Here's a film noir lighting model that's black and white with some really nice high contrast. Here's our basic lighting model, and this one we designed to be as cheap as possible. And so you can see I have that one hooked up right now, and that's the first one that we're going to measure, just because the whole point of making that one was to make a lighting model that would render faster. And so we're gonna measure the performance of this one in just a second. Here's our cartoon lighting model and our simple lighting model that roughly approximates what the scene looked like before, but it uses blend specular, so it should still be a little bit cheaper than the lighting that we get by default in URP. All right, so we have our basic lighting model hooked up. And if we look at our scene, this is what our basic lighting model looks like. And so what I'm going to do now is build this scene, and we'll run it, and we can compare the numbers between the original scene without any changes and this scene that we've created with a simplified, very basic lighting model. Basically, I've removed anything extra. You know, there's no screen space ambient occlusion, there's no specular or reflections. It's just all as basic as we can get. So let's go ahead and we'll come up here under File, Build Profiles, and you can see I've also turned off all the other scenes. So we're just building the garden scene here, and we'll build our scene and then jump into it and take a look at the performance. All right, here is our scene with our customized lighting model. This is our cheapest basic lighting that we're running here. And if we take a look at our frame rate and our performance, it's rendering somewhere between 2.09 and 2.1 milliseconds. And the other one was rendering somewhere around, I don't remember the exact frame rate, but it was like 350, something like that. And now it's running at 470. This is a really significant performance gain. The previous one was at 2.95 milliseconds, and this one's at 2.1. So that's a savings of about 25%. So we've made our scene render 25% faster because we simplified our lighting model. And I'm really happy with the results. You know, if I'm running this on a really fast graphics card at 4K, but if you were to render this on like a low-end mobile device or a VR headset, for example, improving the performance by 25% would be a really significant gain. So this is pretty cool. It's a good reason to go in and customize your lighting model and remove, you know, unnecessary elements from the lighting so that you can get all of the performance possible out of this. Okay, now that you've seen what the process is for measuring performance here, what I'm going to do is go ahead and measure the performance of all of the other lighting models that we had in our scene, and then I'll put up a chart and we can compare and take a look at the numbers. Okay, I've been through the process of measuring the performance of all of my different lighting models. I hooked each of these individual subgraphs up, built the scene, and then ran it outside of the editor and wrote down the timings on all of these. And then I did a little bit of math to compare them with each other. Let's take a look at the numbers. So here's my notepad file that I recorded all of this in. So my original scene with Unity's URP lighting that is built into the renderer, it rendered at 2.95 milliseconds. And so I just used that as the baseline, and we're calling that 100%. Then my simple lighting, which is replacing, basically it's doing the same thing that URP is doing, but just replacing the specular model with a cheaper one called Blinn. Oh, and I also turned off decals on all of these. I probably should have shown you the measurements of what it looked like when decals are on, because decals are on in the original, but they're off for this. And I think it added maybe like 0.1 or 0.2 additional milliseconds to render decals. But our simple lighting model is getting 2.15 milliseconds, which is just about 73% of the original in terms of how fast it's rendering. You can look at the other numbers here, but the cool thing here is that our basic lighting model, where we just stripped out everything extra, and it's basically just doing simplified ambient and diffuse. It's not doing any specular or reflections or anything else. We were able to get it down to right around 70% of the original lighting model. So it's running almost 30% faster than that, which is huge. Like, if you could somehow suddenly gain 30% performance on your project, you'd probably throw your arms up and yell hallelujah. But what I wanted to show here is just like how effective it is when you create your own lighting model and how much additional performance you can gain when you're rendering this, or when you're defining the lighting model yourself, instead of just being locked into using the lighting model that's built into the engine. Now, obviously, there's a significant amount of work involved in building a lighting model, but there's also a significant amount of reward, as you can see here. So this is something that's definitely worth doing if you're willing to not have lighting that's as nice. You're getting rid of features. You know, there's no ambient occlusion, there's no reflections, there's specular, there's no light cookies, so that we're missing a lot of things in order to get this better performance score. But if that's something that you need to do, you can absolutely do that, and you can do it in shader graph. So that's kind of the whole point of this series of videos that I've been creating, is that you can create the lighting model yourself in shader graph. You don't need to be a programmer. You don't need to write code. You can do it right here in shader graph. And I hope I've driven my point home about that, that you have ultimate control over not just the material properties, but also the behavior of the lighting. And you don't have to just stick with the lighting that's built into the engine. You can make your own. And if you do, there's some significant savings on the table for you. Anyway, I hope you enjoyed this video. We may create some additional lighting models in the next couple of weeks, just to kind of round out this series of videos. And then I think we're going to be moving on to a new topic that I'm kind of excited about, sort of related to these numbers that we're looking at here. So with that, I'll end the video. Thanks for watching, everybody. Have a great week, and we'll see you right back here next week.